Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021 Zigbee, its applications and comparison with other short-range network technologies Vishwas KV1, Abhishek v Tatachar 1, Shivanee Kondur 1, Amith R2, Varun YC3, Dr. Kiran YC4 1 Students, Department of Information Science and Engineering, Global Academy of Technology, Bangalore. 2 Student, Department of Electronics and Communication Engineering, Global Academy of Technology, Bangalore 3 Central Queensland University, Melbourne, Australia. 4 Professor and Head, Department of Information Science and Engineering, Global Academy of Technology, Bangalore. Abstract When we talk about wireless short-range communication protocols we often speak about Wi-Fi and Bluetooth. There is another such short-range communication protocol called the Zigbee. When it comes to Internet of Things applications, there are those that have low power requirements and prefer to be cost-effective. Zigbee was formulated on the IEEE 802.15.4 radio standard and was developed to support low-cost, low-power IoT applications. 1. The reason for Zigbee's popularity is its support of multiple network topologies, scalability, and it enables us to connect to local networks without having to give up on reliability. This paper covers the basic concepts of Zigbee technology, 2 important applications of Zigbee home automation and smart irrigation systems, and a comparative study of Zigbee with other short-range protocols such, i.e., Wi-Fi and Bluetooth. Keywords: Zigbee, wireless networks, Zigbee devices, Zigbee Standards, Zigbee Protocol Suite, Zigbee topologies, applications. Introduction. In the present world, there is a huge demand for wireless devices and wireless communication. Zigbee is one such technology that contributes to wireless communication. Zigbee devices that can create a wireless network can create a large network area. The devices are small, low power consumption, the cost is low, and there is a very short time of delay in communication when compared to other devices. 7. It provides a global open standard for wireless radio networks in controlling and monitoring the fields, which include a lot of network devices. Zigbee is mainly used in devices that do not require very high bandwidth and is taken as an alternative to Wi-Fi and Bluetooth and used widely in low-powered devices. Devices such as Amazon Echo, Philips Hue, Bosch security systems use Zigbee as the communication medium, as it uses very less power and mainly suitable for small areas, or so-called the personal area. It supports most of the topologies such as star topology, mesh topology, and tree topology. It has become one of the most used devices for communication in a wireless personal area network, WPAN, and has been acting as one of the most important elements of the Internet of Things, IoT. Zigbee is known for its security and reliability. It supports 128-bit Advanced Encryption Standard, EASE, encryption. The importance of Zigbee has been increased since it follows and uses IEEE 802.15.4 standards and other industry standards. It provides low-power connectivity for devices that run daily and needs long-lasting battery life. The IEEE standards, the physical layer and the MAC layer in the Zigbee protocol suite allows networks to handle n number of devices simultaneously. As it uses IEEE 802.15.4, it provides the concept of low power usage, adaptability to the environment that we are using it in, and connect to local networks for better communication among the devices. 2. Literature survey. The history of Zigbee dates to the 1990s. The Zigbee Alliance, the group of companies that preserve and maintain the Zigbee standard, was formed in the year 2002 to address this concern. The Zigbee Alliance is responsible for the development of open, global standards, certify products and promote the usage of the standards. Zigbee Alliance is over 500 companies, which includes companies such as Amazon, Apple, Legrand, IKEA, Comcast. The Zigbee Alliance is in relation to the IEEE 802.15.4. Looking back at the history, in December 2004, Zigbee v.1.0 was ratified and released in the year 2005 as the Zigbee 2004 specification. Later in the year 2006, Zigbee Alliance launched the Zigbee 2006 specification, which held modification to the earlier Zigbee 2004. In 2007, Zigbee Alliance released Zigbee Pro. On November 2, 2002, Zigbee's first application profile home automation was announced. Following that, other application profiles were released. Smart energy, personal home and hospital care, telecom applications, and many others are among them. Many applications have been developed using Zigbee technology, and many applications have profited from its use. Zigbee is a low-power, low-cost, wireless network technology targeted to support those applications that have low power, cost-efficient and low data rate requirements. The reasons for using Zigbee as a communication protocol for IoT applications are support to a large number of nodes, security, low cost, low power consumption, low maintenance, high security, global usage, reliable and self-healing. 1. Zigbee networks can contain up to 653,356 devices, and these devices can be separated by 50m. This sums up to a significantly large area too. A typical sensor node comprises the following components: a sensing element, a battery, processor, memory, and a communication element. 3. The resulting network of the Zigbee applications would use a very small amount of power so that the individual applications can operate for a year or two using the originally installed battery. 4. The Zigbee structure consists of 3 types of devices: Zigbee coordinator, routers, and end devices. Every network must contain exactly one coordinator who is responsible for storing and handling data and perform operations such as IJERT 10 is 0604112 www.ijert.org 891. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021 Receiving and transmitting data. Routers are responsible to act as an intermediary device and to and fro the passage of the data. 4. 3. Zigbee Protocol Suite. Looking into certain related works. Sujan Shrestha et al. Have indicated in their work on analysis of the Zigbee wireless communication, that use of Zigbee standard communication gives physical as well as media access control layers at very low data rates and also handles more devices. 5. Salim Gibran Danbata and colleagues compared the use of Zigbee, Z-Wave, Wi-Fi, and Bluetooth wireless technologies for home automation. They concluded that when the question is to pick devices from the same manufacturer at a cheap cost and low power consumption, Zigbee is the best fit. 6. Jinqian Li et al. Evaluated the Zigbee-based wireless networks in an indoor environment. They conducted an experiment to evaluate the practical performance of the Zigbee network with the multi-hop transmission in indoor environments over a long operation duration. Zigbee can operate in 3 frequency bands: 868 MHz in Europe, MHz in the United States of America and Australia, and 2.4 GHz worldwide. They have a data transmission rate of up to 250 kbps. From their experiment, they obtained results on node connectivity, packet loss rate, and transmission throughput. During this experiment, they achieved a transmission of 25 kbps, which is substantially less than the 250 kbps nominal value. They conclude that these observed results are due to the transmission overhead and the XMAC random back-off. 7. Zigbee also has applications in the medical field. Mokeng Cao et al. Performed a study on the usage of the Zigbee WSN system that was based on a digital filter mathematical model in post-chemotherapy monitoring and diagnostic value of average fluorescence intensity of peripheral blood neutrophil CD64 for bacterial infections. They performed this study on 128 blood tumor patients who are undergoing chemotherapy. The result of their study was that the filter had suppressed the baseline shift and heightened the detection accuracy. 8. Concluding on the anterior work, we understand a substantial amount of progress and research has been done in the field of Zigbee technology and its applications. Zigbee has a wide range of applications such as home automation, medical application, smart agriculture, etc. We could keep counting and the list would still go on. Zigbee is ideal for all those applications that look forward to being cost-efficient and have low requirements on data transfer rate and power consumption. What we pick up from the literature review is the potential behind this technology. Further in this paper, we have reviewed two important applications of Zigbee Hotel Intelligent Guidance System and Smart Irrigation, for which we picked up the certain kinds of literature that motivated us and which we felt were more efficient. Fig 3.1 Zigbee Protocol Stack. Zigbee Protocol Stack, also known as network layers of Zigbee, contains four layers, namely application layer, network, and security layer, which is governed by the Zigbee Alliance, and the other two layers, namely the MAC layer and physical layer, which are governed by IEEE Zigbee Standards 802.15.4. The Zigbee Protocol Stack is based on OSI, Open System Interconnection, model. The configuration of Zigbee modules is done through XCTU software too. Physical layer. The physical layer of the Zigbee Protocol Stack interprets the physical and electrical attribution of the network. The simple and one of the basic tasks of the physical layer in the protocol suite is data transmission and network reception. Some techniques, such as modulation and some spreading techniques, are used to convert the data. Another work of the physical layer is it helps in enabling and disabling the transceiver. It also helps in assessing the quality of the channels that are between various Zigbee devices. It is also used to assess the quality of the received packets through the channels. MAC layer, as we know that there can be multiple Zigbee devices in an area coordinating together for a particular task, and the MAC layer is defined under IEEE 802.15.4, which explains how the devices share the same radio waves for sharing information among the devices. The MAC layer is responsible for the generation of a beacon if the device transmitting signal is a Zigbee coordinator. Since the devices are placed in a small area, there may be chances of collision. The MAC layer is responsible for collision avoidance, and it acts as a medium for transferring the data to its upper layers. Network and security layer. This layer is responsible for taking up tasks such as setting up a network, end-to-end device connection, routing, configuring different devices in the same network. Zigbee supports 128-bits encryption for security. This layer contributes to providing network-wide security and helps the Zigbee devices to suppress IJERT 10 is 0604112 www.ijert.org 892. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021. Battery usage and extend their battery life to the maximum. It follows mainly three network topologies that are star topology, mesh topology, cluster tree topology, which are considered under IEEE 802.15.4. The Zigbee router is a device that helps in network routing and address allocation for the various devices participating in the topology. Application layer. It is the topmost layer in the protocol suite. This is a layer defined by Zigbee Alliance. This layer consists of three more layers inside an application layer, namely Zigbee device objects, application support sublayer, and application objects. A. Zigbee device object. The main objective of this layer is it provides service discovery, binding, and security. The main work of service discovery is to find the nodes and that are available for communication. As we all know, the security is 128-bit encryption, which aids in data encryption during transmission as well as decryption at the receiving end. The binding service helps in binding several nodes together and recourse it to a specific node and channel. B. Application support sublayer. This sublayer helps in decoding the incoming and outgoing frames from a node. It also plays a major role in managing the cryptographic keys that are used to encrypt and decrypt the data at the nodes. C. Application objects. It is a sublayer that helps in controlling and maintaining all the protocols that are necessary to run a Zigbee device. A Zigbee device can have a maximum of 240 application objects. In a Zigbee topology, the application objects are given a unique endpoint number those other devices can use to communicate with them. In short, it can be called a sublayer which keeps the network address of the Zigbee devices. For Zigbee Standards, Zigbee was initially developed by Zigbee Alliance. This means many companies were included in the development. When we talk about Zigbee, main thing that comes to light is IEEE 802.15.4. Zigbee uses protocols of IEEE 802.15.4 and hence the application and network layer of Zigbee is based on these standards. The Zigbee Alliance makes use of security, network, and application layer protocols. The physical layer for LRWPAN is defined by IEEE 802.15.4, which is hardware. Zigbee operates on an extremely low power level, as low as 1 MW. Under the IEEE 802.15.4, it used a technology called direct sequence spread spectrum, DSSS, which helps in increasing the range of a Zigbee device up to 150 meters. And by using this technology it consumes very little power and hence the power consumption is very low. It provides an 868 MHz bandwidth which works effectively in Europe, and it provides a 915 MHz bandwidth which works effectively in North America and Australia, and it provides a 2.4 GHz bandwidth that works effectively worldwide. In ingredients with IEEE 802.15.4 standards, the Zigbee device adopts 64-bit and 16-bit addresses. Zigbee network can include a maximum of 653,356 devices. Based on the IEEE standards for Zigbee, the maximum distance between any two devices is set to 50 meters. Zigbee topologies. Zigbee stack is responsible for the formation of the network, which is in the Zigbee network layer. There are three Zigbee network topologies: star, mesh, cluster tree. Zigbee uses IEEE 802.15.4 2003 specification for the physical layer and MAC layer. IEEE 802.15 offers topologies star, a cluster tree, and mesh. A star topology, it is made up of coordinates as well as end devices, nodes. All the end devices are connected to coordinates and are both physically and electrically separated. The coordinator must handle all packet exchanges between the devices. The benefit of a star topology is that it is straightforward, and packets must pass through 2 hops to reach their destination. The downside is that all packets must pass via the coordinator, which may cause bottleneck. Also, there is no other path from source to destination. Fig 5.1 Star topology. B mesh topology. Peer-to-peer networks are another name for mesh topology. It is made up of a coordinator, as well as many routers and end devices. It is a cluster tree topology extension. A mesh topology is a multi-hop network in which packets go through numerous hoops before arriving at their destination. If one of the paths fails, the packet attempts to reach the target through another route. In a mesh topology, adding or deleting devices is simple. Any device in the network can communicate with any other device. Fig 5.2 Mesh topology. IJERT 10 is 0604112 www.ijert.org 893. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021. C. Cluster tree topology. A peer-to-peer topology, which is a subset of the tree topology, is referred to as a cluster tree topology. A cluster is made up of a parent and its child, each of which is recognized by a cluster ID. The cluster tree topology is supported by IEEE 802.15.4 but not by Zigbee. The routers increase the network's range, so the end devices do not have to be inside the coordinator's range. End devices are unable to interact directly with one another, however, routers can connect with other routers and the coordinator. Fig 5.3 Cluster tree topology. Coordinators. It forms the root of the network tree and tries to build a bridge for other networks. Each network has exactly one coordinator. It oversees selecting the network as well as its specifications, such as the radio frequency channel, network identity, and others. It also keeps network and security key information. Router. Zigbee router is an intermediate device in a network. It routes the data from source to destination. A router can join a network that already exists. With the help of Zigbee routers, a network may be expanded. It may also accept connections from other devices and function as a network retransmitter. End devices. An FFD or an RFD can be used as an end device. Sensors and switches provide them with a wealth of data. The end devices depend on a coordinator or router to send the data, and it cannot relay data from other devices. These devices can be low power, or battery-powered devices and have limited computer capabilities. The end devices are not needed to stay awake the entire time, although the devices of the other two must. Each of these devices has 240 end nodes, each of which is a separate application with the same ratio. 6 Zigbee devices. Zigbee devices are a combination of Zigbee logical and physical device types. A Zigbee physical devices. In IEEE 802.15.4, based on data processing capabilities, physical devices are of two types: full function devices, FFD, and reduced function devices, FRD. Full function devices, FFD. This type of device can do all the standards functions, including routing, coordination, and sensing. It can function as a coordinator, router, or end device. An AC-fed main supply will power the FFD in a Zigbee network, since it must always be operational and listening to the network. Reduced function devices, FRD. It implements a limited version of the IEEE 802.15.4 protocol. It has the least computing capability. They do not route packets, and they should be associated with an FFD. RFD's main goal is to find an available network to transfer data, to check whether there is any awaiting data, and make a request for the data to the network coordinator. These are end devices like sensors and actuators that have a limited set of operations, such as reading temperature data, monitoring light, or regulating other equipment. B. Zigbee logical devices. There are 3 Zigbee logical devices: coordinators, routers, and end devices. Fig. 6.1, Zigbee devices. 7 Zigbee applications. We have reviewed 2 applications in the perspective of the usage of the Zigbee technology: Hotel Intelligent Guidance System based on Zigbee technology 9, and Automated Irrigation System using WSN and GPRS Module 10. A Hotel Intelligent Guidance System based on Zigbee technology Xiao Yan Shen, ETL put forward an intelligent guidance system that helps people to navigate through the guest room corridors. Hotels and guest rooms are of large sizes. They are internally divided into multiple sections. These include the entertainment area, food stalls, rooms, and accommodation places, and many more sections. This makes it not so convenient for the people who are not IJERT. 10 is 060412 www.ijert.org 894. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021. Familiar with the hotel plan? Most of them use ushers or guides to navigate to their rooms or to their destinations. The purpose was to design an intelligent system that could provide the customers with a more expedient method to navigate. This system made use of the Zigbee technology to connect the handheld devices, the guidance modules, and the control modules. This system uses the Zigbee communication network on the one hand, and the Zigbee ad hoc network capabilities on the other, to achieve the proximity guidance effect. Zigbee 3.0 IP is compliant in every way. 11. This lets several devices interact over the same network, system compatibility, and extension for new devices. The room's guidance data, which is kept in a guidance module, is updated, and sent over the Zigbee network. When a handheld device approaches the guiding module, it picks up a significant signal strength from the module due to the ad hoc network protocol. The guiding module will connect to the network after switching to the parent module. The portable module would then send a request to the parent node, and the guidance module would respond by displaying the guidance information on the screen, assisting the client in finding their way out to their rooms. This technology also displays a way to exit in the event of an emergency, improving the customer check-in experience and the hotel's competitiveness. Because of these factors, the authors believe it has a promising market application. B. Automated irrigation system using a wireless sensor network and GPRS module. Joaquin Gutierrez et al. Have worked on an automated irrigation system that optimizes the water usage for agricultural crops. This system comprises of two components. One is a wireless sensor unit, WSU, and another is a wireless information system, WIS. This allowed the transfer of data such as temperature and soil moisture, implementing a wireless sensor network using the Zigbee technology. Several WSUs can be implanted in the field to constitute the wireless sensor network for the automated irrigation system. Each of these WSUs are based on the PIC24FJ64GB004 that controls the XB Pro S2. These WSUs are configured. For example, the end devices were required to deploy a networking topology point-to-point based on a coordinator which was implemented using an XB radio modem of the WIU. The end device's job was to join a Zigbee Personal Area Network, PAN, before it could send or receive data, not to allow other devices to join the network, to always receive and transmit radio frequency through its parent, to adopt low power modes to save power, and to be battery powered. These WSUs pick up the data such as the soil moisture and the soil temperature from analog digital ports. The data so collected is packed along with the corresponding identifier, date, and time, and transmitted via XB radio modem using an RS-232 protocol through two digital ports that are configured American Samoa, the transmitter, TX, and the receiver, RX. After sending the data, the WSU goes to sleep mode. This enables power saving. The first time the WSU is launched, it inquiries the WIU for the date and time to program the RTCC and periodically synchronizes. The data received from each WSU is recognized, recorded, evaluated, and processed at the WSI. The WIS is a PIC24FJ64GB004 microcontroller with an XB radio modem. In addition, we have a separate GPRS module. The WIS is now ready to provide the date and time back to the WSU when the query has been completed. Finally, the WIU delivers the data to the server over HTTP via the GPRS module once it has been processed. 8. Comparison between short-range communication methods like Zigbee, Wi-Fi, and Bluetooth. Zigbee is a wireless technology, which holds a suite of IEEE 802.15.4 based specifications for communication protocols. This communication protocol is less expensive and similar to the other proprietary short-range wireless sensor networks. It supports different network configurations. Wi-Fi stands for Wireless Fidelity, which holds a suite of IEEE 802.11 for local wireless networks. Wi-Fi is an alternative network to wired network which is commonly used for connecting devices in wireless mode. It connects the computer one another and mutually, to the internet and wired networks. Bluetooth is a wireless technology that allows the exchange of data between different devices. It uses wavelength to transmit information, which works within a short distance for the devices to stay connected. Basis Zigbee Wi-Fi Bluetooth standard. Zigbee has a technology based on IEEE 802.15.4 standard. Wi-Fi has a technology based on IEEE 802.11 standards. Bluetooth has a technology based on IEEE 802.15.1 standards. Frequency range is 2.4 GHz worldwide. Frequency range is 2.4 GHz and 5 GHz radio frequency. Bluetooth's frequency range may vary from 2.4 GHz to 2.483 GHz. IJERT 10 is 0604112 www.ijert.org 895. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021 Phase Shift Key. It uses binary phase shift key, BSPK, and quadrature phase shift key, QPSK. It uses binary phase shift key, BSPK, quadrature phase shift key, SQPSK, complementary code keying, CCK, and coded orthogonal frequency division multiplexing, COF. It uses Gaussian frequency shift keying modulation technique. Power consumption. Best quality of Zigbee is the rate of power utilization as well as battery life of it. Wi-Fi is high power consumption. Bluetooth is low power consumption. Bandwidth. The bandwidth requirement is low but greater than Bluetooth's bandwidth most of the time. Wi-Fi requires high bandwidth. Bluetooth needs low bandwidth. Radio signal range. Radio signal range is 10 to 100 meters. The range of Wi-Fi's radio signal is 100 meters. Radio signal range of 10 meters. A Zigbee has more than 65,000 node cells and 16 RF channels. Wi-Fi has 2007 node cells and 14 RF channels. Bluetooth's maximum of 8 cell nodes and 79 RF channels. Range. Zigbee range is 291 meters. Wi-Fi range is 50 meters. A range for Bluetooth is 77 meters. Table 1, comparison between Zigbee, Wi-Fi, and Bluetooth. The user's choice of wireless technology is entirely dependent on the requirements of the chosen wireless solution. When it comes to cheap cost and power consumption, Zigbee is the finest option. If simplicity of use and range is important, Wi-Fi is recommended. However, if cost is a problem, Bluetooth is a better option. 9 Advantages and disadvantages of Zigbee. The reason for Zigbee emerging in its prime are the advantages that it has provided to the user. We have listed the advantages below. The Zigbee network can be set up very easily. It is easy to control and monitor. It is a low-power device. The resulting network will use significantly less power. Each end device will have a battery life of approximately 2 years. It is scalable, i.e., it is very simple and easy to add or remove Zigbee end devices to the network. The number of nodes that Zigbee supports is large, which is approximately equal to 6,500. Zigbee can be used as an alternative to Bluetooth and Wi-Fi technologies for home automation and smart systems. Zigbee is compatible with products manufactured by different companies. Zigbee offers mesh topology unlike Bluetooth and radio frequency, which operate on the basis of point-to-point communication. Setting up cost is less than a Wi-Fi network as routers are not required, which reduces the cost of implementation. Hence it is more suitable for connecting devices across larger areas. No data is transferred between Zigbee devices without encryption. It utilizes IEEE's Advanced Encryption Standard, encryption with a key length of 128 bits, 16 bytes. The IEEE's algorithm is used to not only encrypt but also to verify the data that is delivered. There are certain disadvantages also, that have to be taken into account. The disadvantages are, Zigbee has lower transmission rates in comparison with Wi-Fi. Although Zigbee offers encryption, it is not as secure as Wi-Fi-based systems. Another major disadvantage is that it is not compatible with consumer electronics such as smartphones, laptops, tablet, computers, etc. IJERT 10 is 060412 www.ijert.org 896. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021. It is susceptible to network interferences as it uses the 2.6 GHz band, which is also used by Wi-Fi, cordless phones, and microwave ovens. Future scope of Zigbee. Although Zigbee seems flawless, and has so many outstanding features, there is still room for further improvement. Zigbee provides a basic level of security using encryption of data with the help of a network key, it is still vulnerable to a potential data breach. User data can be stolen and used for unethical purposes. The encryption keys will give access to the node and network. Therefore, security keys that are used must be protected. There are high chances that a node can be removed from the current network and moved to another network where the hacker can control and gain access to your entire network. Loss of network service by jamming the channel or the entire bandwidth by means of interference can bring down the node. Hacker records the signal transmitted by any one of the nodes. Later the command is sent to a node by the hacker to achieve subversive control. This can be tackled by regularly changing the network key, which is tedious. These are a few areas where Zigbee can improvise in the upcoming days. 12. Conclusion. In this paper, we have discussed in detail the various topologies that can be achieved with Zigbee, namely, mesh, tree and star topology. The mesh topology is used in most of the applications. The three types of devices that form a Zigbee network, the coordinator, the router, and end devices. We have also discussed the advantages and disadvantages of using Zigbee technology and a detailed comparison between Zigbee, Wi-Fi, and Bluetooth technology. We also discussed the different types of layers that Zigbee technology is built on, the physical, medium access control, MAC, the network, and the application layers. Zigbee has a huge list of applications. In the Zigbee applications we have considered two applications from the perspective of Zigbee network technology utilization: hotel intelligent guidance system based on Zigbee, and the second one being, automated irrigation system using a wireless sensor network and GPRS module. We see that Zigbee plays a prominent role in each application, in both ways: ad hoc networks and the communication facility. Zigbee is the most preferable networking option considering the parameters such as power consumption, range, bandwidth, cost of implementation and data transfer speeds. Zigbee also provides a pretty good level of security for the users. The type of networking technology to be used depends mainly on the project you are working on and the user's expectancy. We can conclude that Zigbee is an ideal technology for use in home automation and industrial automation. References: 1 Chellappa, Muthu, and Madhusamy, Shanmugaraj and Prabhakaran, R. 2011. Study on Zigbee technology. 297 to 301 10.1109/ISEC Tech.2011.59421002. 2 Parneet Dhillon and Dr. Harsh Satawardi, 2014. A review paper on Zigbee, IEEE 802.15.4, Standard. 3 Madhusamy, Shanmugaraj, and Chellappa, Muthu and Prabhakaran, R. 2011. Industrial monitoring using Zigbee network. 10.1078-3-642-19542-6_130. 4 Komal Pasri Shah, Harshita and Sadhana Rana. 2017, An Analysis of Low-Cost, Low-Power, and Futuristic Wireless Technology Zigbee. International Journal on Emerging Technologies, Special Issue It's 2017, 8, 1295-297, 2017. 5 Sujan Shrestha and Sabarna Shakya, 2020. Technical Analysis of Zigbee Wireless Communication. 6 S.J. Danbata and A. Viral, Comparison of Zigbee, Z-Wave, Wi-Fi, and Bluetooth wireless technologies used in home automation, 2019 7th International Symposium on Digital Forensics and Security, ISTFS, 2019, pages 1-5, doi, 10.1109/ISTFS.2019.8757472. 7 Jinqian Li and Yuan Ming Wang, 2013. Experimental Evaluation of Zigbee-based Wireless Networks in Indoor Environments. Hindawi Publishing Corporation, Journal of Engineering, Volume 2013, http://dx.doi.org/10.1155/2013/2863678 Mo Keng Cao, Junjing Wang, Chunfeng Wu, Azil Takshi, Bishr Mohammed Muwafaq, the Zigbee Wireless Information Medical Monitoring for Bacterial Infections using Filter Mathematical Model, Results in Physics, Volume 25, 2021, 104320, ISSN 22113797 https://doi.org/10.1016/j.rin.2021.104320. 9 Xiao Yanshen, Weixiao, Zhengjiang, Pengsu, Hotel Intelligent Guidance System based on Zigbee technology, microprocessors, and microsystems, Volume 77, 2020,103160 ISSN 01419331 https://doi.org/10.1016/j.micpro.2020.103160. 10 Gutierrez, Joaquin, and Villamedina, Juan and Nieto Garibe, Alejandra, and Portagandara, Miguel. 2014, Automated Irrigation System using a wireless sensor network and GPRS module. Instrumentation and Measurement, IEEE Transactions on 63 166 to 176. 10.1109/Tim.2013.2276487. 11 C's links. 2017, The Power of Zigbee Registered Trademark 3.0. F. Corvo Low Power Wireless. White Paper, 12 Pashutanizate AM, Rafa Z Social Media Marketing, Determining and Comparing View of Public Library Directors and Users. IND Mark Managed 2019, 1:117. IJERT 10 is 060412 www.ijert.org 897. This work is licensed under a Creative Commons Attribution 4.0 International License.